Welcome to two projects. In this video, we are going to explain the project CloudChain, integrating Ethereum blockchain for secure and scalable cloud services. Before diving into the execution, let me give you an overview of the project. So, CloudChain is a decentralized data storage system that combines cloud computing with Ethereum blockchain technology. It offers a user friendly interface for data management and uses IPFS, that is interplanetary file system, for storage, breaking files into small pieces and storing them across multiple locations. The Ethereum blockchain stores unique hash addresses of files in IPFS, making it easy to detect unauthorized changes. The proof of work mechanism verifies data integrity by requiring computational work to validate new transactions, making unauthorized changes difficult. So, this combination ensures data security, scalability, and efficiency in data storage and access. Traditional methods of doing this, of storing data in the cloud, face several challenges related to security and reliability. Data stored with a cloud service provider is usually kept on centralized servers, which are vulnerable to hacking and other security breaches. Additionally, there is the risk of internal threats where employees of the cloud provider might access or tamper with the data. Furthermore, detecting unauthorized changes or tampering with the data can be difficult using traditional methods, leaving the data vulnerable without proper monitoring and security measures. So, there comes blockchain technology. Blockchain is like a digital ledger that records transactions securely and transparently. In this project, it stores hash addresses of files in IPFS, ensuring data integrity through the proof of work mechanism and hash verification. Each data entry is a block linked by unique hashes, forming an immutable ledger. So, blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes or computers go down, others continue to maintain the data. So the blocks are stored in different computers. The copy of blocks are stored in different computers. So if one computer goes down, we can get the data from other computers. So this makes it resilient to failures. And there are many types of blockchain like Ethereum, Stellar, Ripple, Bitcoin, etc. We are using Ethereum blockchain in this project. Ethereum is crucial to Cloud Chain's architecture due to its support for smart contracts, which streamlines processes such as storing and retrieving hash addresses, ensuring data integrity without a central authority. Its decentralized nature enhances security by distributing data across multiple nodes or computers, making tampering difficult. And the project also integrates Ganache and MetaMask. Ganache is a personal blockchain for Ethereum development used in CloudChain. It provides a user friendly interface for deploying smart contracts, running tests, and inspecting blockchain states. Ganache tracks accounts, transactions, and smart contracts, offering detailed transaction information to aid debugging and ensure accuracy. It also allows developers to access and analyze specific block information, simplifying monitoring and verification processes. Coming to MetaMask, MetaMask is an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to decentralized applications, that is dApps. So in this project, MetaMask ensures secure Ethereum transactions, showing the deduction of ETH as fees to promote transparency and maintain accuracy. Its ease of use facilitates interactions with blockchain applications, enhancing the overall user experience. Overall, the integration of blockchain in CloudChain ensures data integrity and security by storing hash addresses of files in IPFS, and this project benefits end users, cloud service providers, and developers who need secure and reliable cloud storage. So, Cloud Chain enhances data security, ensures data integrity, provides scalable storage solutions, and develops an easy to use web interface for uploading and retrieving files. By combining the scalability of cloud computing with the security of blockchain, Cloud Chain offers a robust and secure data storage solution. So, this is about the project. Now, we look at the software and hardware requirements to execute this project. Software requirements are Python, ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, and Solidity. Framework used is Django. Front-end languages required are HTML, CSS, JS, and Bootstrap 4. Hardware requirements are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. So these are the requirements. Now we'll see the execution. Before execution, first we need to open the code folder, which contains the project source code files. So this is the code folder, and these are the contents I have in the code folder. This is cloud folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is cloud app folder. So this folder comprises a static folder which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspects of the application. Cloud app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is manage.py file. So it is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is smart contract SOL file. So this file consists of Solidity code. It handles data structures, functions, and events with modifiers for validation. This is run.bat file to start the IPFS server. So by double clicking on this, we can start the IPFS server. IPFS is a decentralized file storage system for secure and distributed data sharing. Blockchain is effective for recording transactional data, but for large file storage like images or documents, blockchain integrates with IPFS, that is Interplanetary File System. And this is run server.bat file to start the application. Before running these run.bat files, first we have to host the Ganache server. Open Ganache. So I have already created a workspace. Click on it. So we can see the Ganache server has been hosted. Now minimize this. First we'll start the IPFS server. Double click on this run.bat file. So we can see the IPFS server has been started. Now minimize this. Now double click on this run server.bat file. Instead of executing the program through command line interface, we have created these Windows batch files. So this file will, by double clicking on it, It will compile the manage.py file. The Django framework will host the application locally at the default address, local host, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Django framework. So here we can see user login and new user sign up links. If you are new to the system, we have to register ourselves first. So click on new user sign up link. Here we have to fill in these details and click on submit button to register. So username would be Ramesh. Give the password. Give the contact number. Select the gender from the drop down. I'm giving it as male. Give the email ID and the address. Now click on submit button. So here we can see sign up process is completed and record saved in blockchain. So all these user details which we have given will be stored in blockchain in a form of block. We can see that in Ganache. So we can see a block has been created in which all these user details which we have just entered will be stored. So we can see the block number here. We can see the date and time at which the block has been created. So on this date and on this time, these details have been stored in this block. And this is gas used. So this is the gas used for this transaction. Now minimize this and in the MetaMask wallet, click on the Chrome extension. So we can see I have a balance of 99.9972 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. So in the context of blockchain, transactions refer to the actions or operations that are recorded on the blockchain ledger. Example, creating an account, that is registering a person, is a action here. So this is my ETH balance now. Now we'll log in. Click on user login link. Give the credentials of Ramesh here and click on login button. So we have logged in as Ramesh. Here we can see upload file to cloud, access file from cloud and logout links. Click on upload file to cloud link. So here we can upload any file to the cloud. So we have to click on this choose file button and select the file to upload. So click on choose file. I'm selecting this file. So this is the file I wanted to store. Select the file and click on open. Now click on submit button. So here we can see shared data saved in blockchain with below hash codes and files saved in IPFS. So the details which we have given are stored in blockchain, that is the user details and all. And the file which we have uploaded is stored in IPFS. So long files, the large files will be stored in IPFS. Files like documents and images will be stored in IPFS. And IPFS will provide us a hash code. So this is the hash code. This hash code will be saved in blockchain, making it immutable. So the file we have uploaded is stored in the blockchain. Now click on access file from cloud link. So here we can see the details of the file which we have uploaded, data owner. So Ramesh has uploaded the data. We can see the IPFS file address here, uploaded date and time, and the file name. So this is the file name. And here we can see a download file link. By clicking on it, we can download the file in its decrypted format. The file will be stored in its encrypted format, but while downloading it, authorized users can download it in decrypted format. So I'm clicking on download file link. So we can see the file has been downloaded. So the project uses ECC algorithm to encrypt the file and decrypt the file while downloading. We can see that in Ganache also. So we can see blocks are created for storing the file which we have uploaded. So we can see the date and time at which the blocks are created. We can see the gas used for that transaction. So now I'm clicking on this block number 12. So here we can see the block hash, the transaction hash. It was mined on this date and time. That is, this block was created on this date and at this time. We can see the gas limit, the gas used. Now click on the transaction hash. Here we can see the sender address, to contract address, gas used, gas price, gas limit, mined in block number 12. That means this transaction data is stored in block number 12. And this is the transaction data. Now minimize this. I'm opening the MetaMask. So we can see ETH balance remains unchanged after each block creation because the project's actions don't involve significant ETH transfers. This is normal as not all operations lead to substantial balance changes. So in this way, we can upload files to the cloud by clicking on this upload file to cloud link, and we can access file from the cloud. The uploaded file will be stored in encrypted format and authorized users can download the file in its decrypted format. Now click on logout. So CloudChain integrates Ethereum blockchain technology with cloud computing, enhancing data security and integrity through decentralized storage and hash verification. By using IPFS for efficient data storage and blockchain for robust security, CloudChain offers a scalable and reliable solution for secure data management and access.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.